Hi guys, since I went over part A of IIS 1.2 yesterday, I'm going to go over B through D. Now, question number 2 and 3 I've already done, and keep in mind in part B, the goal is to change it into slope-intercept form, or y is equal to mx plus b form. So you're collecting the y on one side of the equation. Okay. Number one actually can be tricky because it looks kind of simple. You want to isolate the y, which means that you want to move this out of the way, and in order to get rid of the x, you're going to subtract x from both sides of the equation. When you do that, though, keep in mind that you still have the negative sign, so you have negative y is equal to negative x plus 4, since you can't combine these things because they're not like terms with each other. The problem is you still have one more step because you want it to look like y is equal to, and this still has a negative sign. So you can either multiply or divide by negative 1, and remember to do that to each of the terms to isolate the y completely, and your answer should be y is equal to now positive x minus 4. And here's your slope-intercept form. In this case, the n will be 1, and the b would be a negative 4. Okay, the answer for 2 is y is equal to negative 2x plus 9, and number 3 is y is equal to negative 2x minus 3. A lot of you probably had difficulty with question number 4 because this is all variables, but the idea and the concept is the same. You still want to make it into y is equal to something, and looking at this equation, this is the y that I want to isolate. In other words, I want to move everything else over to the left-hand side. Seeing that this is the x term right here, I can see that this is like mx. This is probably like the number b part by itself. And if I want to isolate the y by itself, I want to move what's further away from the y. So this thing I want to cancel out by subtracting ax from both sides of the equation. When you do that, you're only left with dy on the left-hand side of the equation, but you can't combine these things, so this is going to become negative ax plus c. Now you could have written c minus ax, but I'm keeping it into mx plus b format. Okay. Now, even though we did one step and it looks closer to it being the y being isolated, I still have that d that I want to get rid of. So you're going to divide by d on both sides of the equation to isolate the y, but make sure that you do it to each of the two parts on the left-hand side of the equation. In other words, you'll be left with only y on the right hand side, and the left hand side would be negative a over dx plus c over d. Okay. I would rewrite this as y is equal to negative a over dx plus c over d, like this. And you can see it's y is equal to mx plus b that way. It's okay if you didn't know how to do this one. Question C, I already did question number 1. The only thing you needed to do, and in part C, what you're trying to do is take something and change it into standard form. So you want to collect the variables on the same side of the equation and the number or the constant on the other side of the equation. I saw that the variable y was already on the left-hand side, but I also had one on the right-hand side, so I moved it over, and that one step will get you to a standard form. Now, question number 2, I actually have the question written twice because I'm going to show you how to do it 2 different ways, or 2 correct answers. And line down the equal sign. First, you're going to observe the question and say, okay, I have a variable over here, a variable over here, and a number over here. So I want to move the variable to the left-hand side. In order for me to move that over to the left-hand side, subtract 3/4 x to both sides of the equation. And I'm going to put the x term first, negative 3/4 x plus y, since you can't combine unlike terms, is equal to 1/4. And you can be done with here. Okay? If you look at the end result, the variables are on the left-hand side of the equation. The numbers are on the right-hand side of the equation. So this is in standard form. Now, the reason why I wrote another one is because if you wanted to, you actually can get rid of all the fractions. And you don't need to do this, but a lot of people find it easier to look at equations without fraction. Now, if you look at this, I have, again, the variables are on both sides of the equation, but I have a 4 as a denominator. If you want to get rid of that, you can do the same exact thing to both sides of the equation and multiply every single part by 4. So multiply by 4 here, multiply by 4 here, and multiply by 4 here. That's going to leave me with 4y is equal to, these 4's will cancel out to say 3x, and these 4 will cancel out to come up with a plus 1, and now I have an equation that has absolutely no variables. I'm still not done though, because you still want to move all the variables to the left hand side of the equation. So just like before, the x term needs to move over to the left hand side by subtracting 3x, and I'll have negative 3x plus 4y is equal to just that one that's left over. Okay. Again, if you look at the end results, the variables are on the left hand side of the equation and the numbers on the right hand side of the equation. So these two, although they look different, they are equivalent, and both equations are correct. Okay? So again, in part C, you were going into slope-intercept form, and on part B, you were going into slope-intercept form, and in part C, you were going into standard form. Okay? We have 2 more questions in part C to go over. Okay? Which, number 3 I already did for you, and 4 again is the one with a variable that may look a little bit more confusing, so I'm going to walk us through this one. Okay? Looking at this equation, something y plus 3 is equal to something x minus 15. So I'm looking at this and saying, okay, these are the x and y variable terms, and the 3 and the 15, or negative 15, are the number terms. So I want to collect all the variables on the left and the numbers on the right hand side. If I want to move this variable to the left hand side, subtract gx from both sides of the equation, and I'll be left with, well, actually let me write this one first, negative gx, it's a positive fy, I still have that positive 3, is equal to now negative 15. Okay? So I did collect the variables on the left hand side, but I still have a number on the right left hand side that I need to move over. So subtract 3 from both sides of the equation, and you'll be left negative gx plus fy is equal to, this I can combine like terms and say negative 18. So here is your answer in standard form. Something x plus something y is equal to a number. Variables on the left hand side, number on the right hand side. Okay. Lastly, I wrote down the problems for letter D, and I wanted to always have you keep in mind what the let statement is, what you're representing x and y to be. So Mary is selling popcorn for $5 per bucket and hot dogs for $4.75. She makes $72.50 in total. So for this, the number of popcorn would be your x variable, number of hot dogs would be your y variable. So if I were to say 5x, that's going to tell me how much money I make from the popcorn. If I say 4.75y, that's going to tell me how much money I make on the hot dogs. Because if you can imagine with a number, say that I got 10 buckets of popcorn, I'll do 5 times 10 and I say $50 on popcorn, right? Okay. Either way, when I add how much I make from the popcorn and how much I make from the hot dog, she made a total of $72.50. So if you look at the equation, the price for popcorn plus price of hot dog is equal to total price. The variables are on the left hand side, so this is actually in standard form. And it totals the number of total dollars. Whereas question number 2, it says Matt is selling roses. Each rose is $3.75, and the expenses, how much it's going to cost him to buy the roses is $25. And write an equation for profit. Okay? So in this case, the x is going to be the number of roses he sells, and the y is going to be the profit. Now, if you think about how we can figure out how much money he's going to make, let's say that he sold 100 roses. He'll do 100 times $3.75 to find out how much money he made, but he spent $25, so you have to subtract that. In other words, 3.75x is going to tell you how much money you make, and then you have to subtract the expenses of $25, and that's going to give you how much money you make. So if you look at it that way, y is equal to 3.75x minus 25, and it would be in slope-intercept form. For this word problem. So depending on what kind of word problem it is, it might be easier to write it sometimes in standard form, sometimes in slope-intercept form. Okay, you have some homework questions to do. Make sure that you ask me any questions if you have any. Have a great weekend.